Aim of this experiment is effect of acetylcholine on rectus abdominis muscle of frog.
Objectives of this experiment are to know that rectus abdominis is a skeletal muscle, to locate rectus abdominis on abdominal wall of frog, to observe and understand rectus abdominis is responsible for compression of abdominal organs and to flex the vertebral column in lumbar region, to understand that acetylcholine is responsible for contraction of rectus abdominis.
Rectus abdominis muscle of frog is a skeletal muscle. Skeletal muscle functions to move bones of the skeleton and thereby regulate movements of the body. Skeletal muscle tissues are also known as striated muscle. Skeletal muscle are voluntary type and are controlled by nerve cells of somatic system. Muscle tissues have special properties like excitability, contractility, extensibility, and elasticity. The contractile element of skeletal muscle is called myofibril. Myofibrils are small in structure, about 2 micrometer in diameter, and extend the entire length of a muscle fiber. Myofibril contains thin and thick filaments. Filaments are arranged in compartments called as sarcomeres. Sarcomeres are functional unit of a myofibril. Myofibril has prominent striation because of filaments, and entire muscle looks striated. A physiological contact between somatic nerve cell and skeletal muscle is called neuromuscular junction. At this synaptic junction, acetylcholine is released from the end plate of somatic nerve cell. Acetylcholine is a natural neurotransmitter at neuromuscular junction, and after its release, it interacts with nicotinic receptors of skeletal muscle. This interaction is responsible for muscle contraction. Acetylcholine, after interacting with nicotinic receptor, induces change in membrane potential and induces influx of sodium ions and calcium ions inside the cell. This leads to muscle contraction.
Assembly setup. The assembly setup for experimentation of frog's rectus abdominis muscle preparation consists of organ bath. The organ bath consists of an outer jacket, which is also known as water bath, made up of steel or glass. Organ bath also consists of thermostatically controlled heating rod, which maintains uniform temperature of water in outer jacket. It also consists of tissue bath, made up of glass with a capacity from 10 to 50 ml with both sides open. Isolated muscle preparation is mounted in upright position in this tissue bath. Aeration tube made up of glass has dual functions. One, it will aerate mounted muscle preparation, and second, it serves as the tissue holder. The other end of tube is connected to aerator. The bottom end of tissue bath is connected to rubber tubing which serves as outlet. The bottom side of organ bath consists of an outlet for removing water from outer jacket. Recording lever. To record the responses of drugs on muscle preparation, one can use either simple lever or frontal writing lever. Frontal writing lever is made up of light aluminium and is designed in such a way that the writing tape rotates freely about its axis. For proper recording of responses, adjustment of magnification of lever is necessary. Magnification value is calculated by using following formula. Magnification value is equal to distance between fulcrum and writing point upon distance between fulcrum and the point of attachment to the tissue. For recording the effect on frog's rectus abdominis muscle, 5 to 10 fold magnification is required. For proper recording of responses and for proper relaxation of muscle preparation after drug effect, application of proper tension or load is required. For example, for frog's rectus abdominis muscle preparation, the tension prescribed is 1 to 5 gram. This tension is applied on longer arm of the lever. Sherrington's rotating drum. It is also known as chymograph. It consists of circular drum, speed regulating gear, shaft to which drum is connected, and main on or off switch. It has clutch lever, screw lift to alter the position of drum, and electrical striker. Chymograph paper is wrapped on circular drum and is smoked with black smoke of kerosene or benzene. To study the effect of acetylcholine on frog's rectus abdominis muscle, select healthy frog. Pith the frog with the help of pithing needle. Now, pin the limbs of the frog to dissecting tray. Remove the abdominal skin to expose rectus abdominis muscle. To isolate rectus abdominis muscle preparation, take side cut on rectus muscle. One can prepare 2 muscle preparation from a single frog. Now, tie a thread to the bottom and top of rectus muscle before removing muscle from the body of the frog. Mount this rectus muscle preparation in upright position in the organ bath containing frog ringer solution under a tension of 1 to 5 gram. Now relax the tissue or muscle for about 45 minutes, during which wash this preparation with fresh quantity of ringer for at least 3 times. Now this preparation is ready for experimentation. You have learnt that acetylcholine shows nicotinic actions at neuromuscular junctions of skeletal muscle. The contraction of muscle is achieved by triggering muscle action potential. Acetylcholine also increases spasmodic action of rectus abdominis.